Hello, welcome. This is the third video of the series on construction schedules. In the previous videos, we learned we went through the steps of the process of developing a construction schedule. So went all the way until the last step here. So we've seen how to develop the sequence and then build the construction schedule network, knowing that we have information from WBS. So we have the activities list and we have the production rates and quantity takeoffs, so we can estimate the durations of the activities. So the next step would be identifying the schedule times and also floats. So this video here we're only covering activity times. So we'll learn how to do that, and then there will be a last video we'll talk about floats. So we will also see that. So schedule calculations are done in different methods and scientifically, and researchers come up with different ways of doing the schedule calculations, accounting for different factors. But critical path method is really the classical, traditional way of doing schedule calculations. So let's explain CPM using this simple example here. So we have 4 activities. A through D. I have identified their immediately preceding activities. We call them in the previous video IPA, so just clarifying that. And then I know also the duration. So we will explain CPM as a concept through drawing the bar chart and analyzing that bar chart. So one thing you will see that when I draw the bar chart, I kind of, while I'm not aware of it, but I'm actually doing CPM calculations. At least one pass of it, not the whole process, but we'll see that. So A is a starting activity, so it starts at day or time 0, and it has 5 days duration, so 0 to 5. B and C depends on A, so they start at the same time, but at different durations here, they end at different finish times. And then D depends on both B and C, so the latest of them is 10. So starting from 10 for 5 days, that will be 15. So the project duration here is 15. But if I look here, if I'm trying to classify the activities here, what's special about A, B, and D? I want you to pause here and think, if you compare between, I tell you they are different. So now if we compare between them, A, B, D, and the last activity you see, what's different? So if you think about it, A, B, and D are kind of the sequence of activities that led to 15 as a project duration. So what we call them the critical activities. So if I push A only 1 day, the whole project will be pushed 1 day. All right? But if I push C 1 day, I will not be worried that much. If C is delayed, I will not be worried. But if A or B or D are delayed, then I will be worried. If I'm managing this project, I will be freaking out. All right? So that's basically the difference. So C is not a critical activity. It can be delayed 1 day, it can be delayed 2 days, and even 3 days. After 3 days, I will start freaking out. I will start, getting worried, what's happening, but I still have I have some flexibility in dealing with C. So the earliest time to do C is 5, beginning of day 6. And also, that's because technically I cannot do it earlier than that. It depends on A, and A takes 5 days, so I will start at the 6th day. But I also have flexibility in starting it on the 9th day or at the end of the 8th day. So I have here basically a slack or a flexibility of 8 minus 5, 3 days. So now this is a small schedule. I can do that mentally. It's a mental exercise, easy to do. But imagine a schedule with hundreds and sometimes thousands of activities. You can't do that. I mean, there are long series of activities that you can't. It's very complicated to mentally do that. So there is a structured way of doing or finding the times of the activities and their conditions in terms of what are the flexibility of scheduling them, which is called critical path method. So we'll do the method here is mainly two steps. The forward pass, which is you start from the project's beginning at time 0, and then you do the forward pass, which when you do the forward pass like we did in the last exercise, you end up with the early times of the activities. And once you reach finish the whole path, you end up also identifying the total duration of the project. And then, which we didn't do, going backward, doing some backward pass calculations, and that will give you the latest time that activity can finish. And as a check, you should always end up with 0 time as your start time for the project. So that's basically critical path method, is you have forward pass and you have backward pass. When you do the bar chart, you kind of do the forward pass. But we will learn how to do critical path method on the activity on node representation of the network. And let's agree here on this legend or key for how to draw the network and the nodes. So this is just one activity, and I'm drawing or describing here all the information about the activity that will be completed at the end of that scheduling exercise. So I have the duration, description of the activity, early times, early start and early finish, and then late times, late start, late finish, and then floats, total float and free float. These are the things that we'll learn how to calculate using CPM. In this video, we'll learn with the focus on the times, early times and the late times, and the next video we'll learn about floats. So forward pass calculation. For the initial activity or the starting activities, you set the early start to be 0. For any other activity, the early start will be dependent on the early finish of their predecessors. So while we're drawing bar charts, we have seen that in action. So just putting it in a mathematical formula here, early start of an activity is equal to the maximum of the early finish of the preceding activities. So if I have EF1, early finish of activity 1, early finish of activity 2, this third activity is dependent on both of them. So this early start of that activity is the maximum of two numbers that I have, EF1 and EF2. Now for early finish, if I already know the early start of an activity, early finish will be basically adding the duration. And that's it. So you're just moving forward like that. And at the end of the project, when you've done all the forward pass calculations for all activities, the largest early finish you found will be your project duration, total project duration. So as an example here, A and B are predecessors of C. A finishes 7, B finishes at 9. So C start, early start will be the maximum of 7 and 9. And then you do the duration relation to find the finish, early finish of C to be 12. Backward pass is now you're done with the forward pass, you know the finish of the whole project and the early start and early finish of individual activities. So moving backward, you start from the end of the project, and finishing activities, you start setting their late finish equal to the project total duration. And then any other activity, the late finish will be equal to, that's maybe a little confusing here, but it will be the opposite of the forward pass. So the late finish will be the minimum of the late start of the succeeding activities. So if I have two succeeding activities for that green activity here, I focus on the late start and pick the minimum to be my late finish of that green activity. Once you have the finish, the late finish, you just deduct the duration, you end up with the late start. And so if B and C are successors of A, so B has a late start of 13, C is late start of 17, so the late finish of A will be the minimum of 13 and 17. Why? So let's pause here and think about it. So if let's say I pick 17 as the latest finish of A, so I now kind of say my latest is A, latest time to finish A is 17, sorry. So what happens is if I so relax now to wait until 17 to finish A, C, no problem. I mean, the latest I can wait to start C as 17, but B, the latest for it is 13. Otherwise, so if I finish A after 13, B will start after 13, which is later than its latest early start, which will translate pushing everything after B to the end of the project. So this means that the whole project will be delayed. So this is why when you go backward, you pick the minimum of the late starts of the activities to be the late finish of that of their predecessor activity. And then you do the duration deduction here to move from the late finish to the late start. So let's see this exercise here. We have A through G kind of schedule immediately preceding activities. This is the sequence and duration. This A here has this asterisk, which is a node that says that C depends on A, but there is a lag 1 day between them. So we need here to calculate, draw the activity on node, calculate the early and late times, and then figure out what's the project duration at the end. So this is the network, and remember the legend that I showed before, these kind of different boxes here of if within each node. And if I start from the beginning doing the forward pass now, so I start for time 0 at the start node. Remember, so if you remember, start here is not an activity and end is not an activity, but I created them so I start from one point and end at one point. The start, the CPM calculations at one point, ended at one point. So I start at 0. So A depends on start and B depends on start. So 0 moves here and here. You add the durations, so 0 plus 5, 0 plus 3. And then C depends on A and B. So I pick the maximum of the early finishes of both, but here I have to pay attention to the lag. So after I finish A, I have to stay 1 day doing nothing to start C. So kind of I add 5 plus 1, this is 6, and then coming from here I have 3, so you pick the max will be 6. 6 plus 4 is 10, 10 goes here and there, and then add the durations, 10 plus 2, 10 plus 4. 12 goes to F here, but then I see here G is also dependent on D and E. So 12 goes to F right away, there's no other predecessor, just straightforward. 12 plus 3, 15. Now for G, I have 12 and 14, so I pick the max will be 14 plus 5 is 19. So this means now 19 is the project duration in this case. Now doing backward, copy this project duration to be the latest finish of the last node here, so 19 at the end node, and then moving backward. So numbers flow backward. If I have only one successor for F and for G, then it just flows here backward. I deduct the duration 19 minus 3 and 19 minus 5. E here is easy, you just have one successor, so just one number coming backward, 14 minus 410. But for D, I have two successors, so I have 16 and 14. Remember, backward pass, you pick the least. So you pick 14 minus 2, 12. Then here, 12 and 10, you pick the least. 10 minus 4, 6. And then you move backward. When you move backward, you deduct the lag. You don't add it. So 6 minus 1 is 5. But here I don't have a lag, so you just move as 6. 6 minus 3 is 3. And then as a check for you, if you have one single node as your start of the project, I should start when you move backward pass, you end up also with 0. If you don't end up with 0 here, actually there is something wrong and you have to go back and check your calculations. So this is the CPM calculation. We did the forward pass, the blue values here, and the backward pass, the green, the values. So we have one last video to see, build on that and continue the CPM, expand on it and see what other information we can get out of that, which we call the activity flows. So we'll see that in another video. Take care and have a good day.